Hello everyone, welcome back to my YouTube channel. This is Neha SD, currently pursuing BE in Sri Venkateshwara College of Engineering from the Department of Computer Science and Engineering from 3rd semester Bhaskara section. Today's subject is Mathematics for Computer Science and course code BCS 301. And today's topic is Sampling Variable and Central Limit System. Learning about the sampling variable and the central limit system which is used in mathematics. Introduction to sampling variables. Sampling variables are the essential concepts in statistics that helps in understanding the data distributions. They represent the values that a statistic can take based on the different samples from a population. Understanding the sampling variables is crucial for making inferences about the larger populations. More about the sampling variables, and the definition for it is a process which is used in the statistics analysis in which a predetermined number of the observations are taken from a larger populations. A sampling variable is a variable that represents a statistic calculated form of a sample. It varies depending on the sample chosen from the population. The distribution of these variables allows statisticians to make predictions and inferences. Importance of the sampling variable. A sampling variable helps in estimating the population parameters with a degree of accuracy. They are fundamental in hypothesis testing and constructing confidence intervals. Understanding the behavior underpins many statistical methods or practices. Sampling is divided into two types, that is a probability sampling and non-probability sampling. Move on to the types of sampling now. Common sampling methods include simple random sampling, stratified sampling, and the cluster sampling. Each method affects the variability and the bias of the sampling variable. The choice of the sampling technique can significantly influence the results of the statistical analysis. Distribution of the sampling variable. The distribution of a sampling variable is often referred to as the sampling distribution. It describes how the statistic values from sample to the other sample. The shape of the distribution is influenced by the sample size and the population distribution. Move on to the next topic, that is the central limit system. The introduction to the central limit system goes here. The central limit system is a fundamental theorem in statistics. It states that the sampling distribution of the sampling mean approaches a normal distribution as sample size increases. This theorem holds the true regardless of the population distribution given a sufficiently large sample size which gives an accurate precision. Conditions of the central limit theorem. Central limit theorem. The principle that the distribution of the sample mean approximates a normal distribution as the sample gets size gets larger regardless the population distribution. The central limit theorem applies under certain conditions, mainly sample size. Generally, a sample size of 30 or more is considered sufficient for the central limit theorem to hold. However, if the population distribution is normal, the theorem may hold for smaller sample size or even for the larger sample size. Applications of the central limit condition. The central limit theorem allows for the use of the normal probability techniques in inferential statistics. It enables the statisticians to make predictions about population parameters based on sample statistics. This theorem is crucial for the validity of the many statistical tests and confidence intervals. Examples of the central limit theorem. A common example is the distribution of the sampling means for a non-normal population. Regardless of the initial distribution, the mean of the sufficient samples will approximate a normal distribution. This principle is applied to the various from fields like from finance to biology to analyze the sample data. Realizing the central limit theorem. Visual representation of the central limit theorem typically show the population distribution and the sampling distribution. As the sample size increases, the sampling distribution becomes more bell-shaped. Graphs can illustrate how the means of the sample converges towards a normal distribution. Error of mean. A standard error measures the dispersion of the other sample means that alters the population mean. It is calculated as a population standard deviation divided by the square root of the sample size. A sample smaller standard error indicates more consistent sample means and more reliable large numbers. The law of the large numbers complements the central limit theorem. It states as the number of trials increases, the sample mean converges to the expected value. This law highlights the reliability of the using larger samples for estimating population parameters. The formula for the central limit theorem is the mean formula is population mean, which is denoted by mu. The standard deviation is equal to standard deviation divided by square root of n. Applications of the central limit theorem. The central limit theorem is widely used in the quality control processes in manufacturing. It is essential in survey sampling and the politician polling to estimate the population opinions. Researchers rely on the central limit theorem when conducting the experiments and analyzing the results. Limitations of the central limit theorem. While the central limit theorem is powerful, it may not apply to very small sample sizes. Extreme outer line in the population can affect the distribution of the sample means. The theorem assumes independent sampling violations that can lead to the incorrect conclusions. The limit theorem can also be used in our real lives. The central limit theorem can be observed in the daily life, such as in election polling results. It helps to predict the behavior of averages in the various scenarios from sports to finance. Understanding the control limit theorem can help individuals make informed decisions based on sample data. Let's move on to the last slide, that is the summary of the conclusion of this whole topic. The sampling variables and the central limit theorem are the foundational to the statistical analysis. The central limit theorem enables the application of the normal distribution technique to various sample sizes. Both concepts are critical for making accurate predictions and informed decisions.